Solving simultaneous equations by substitution, 3.3. So we've learned how to solve simultaneous equations by graphing and by elimination method. So this is the third and final method. Remember, simultaneous equations are two or more equations with two or more unknowns. So in this case, we have two equations and two unknowns. So that means we can solve it. So first I'm going to review for you graphing, and then I'm going to review for you elimination, and then I'm going to present the new method. So what you learned in 3.1 was, first let's just graph it. So I'm going to transfer this or change this into y equals mx plus b. So this equation gives me y equals, I'm basically going to subtract x on both sides, negative x plus 6. This equation, I'm first going to add y to both sides, but then I'm also going to subtract 1 from both sides, so I get x minus 1 equals y. So I can go ahead and graph both of these equations. The first one has a y-intercept at 6, so 1, 2, 3, 4, 5, 6, and it has a slope of negative 1. So I'm going to use my graphing tool to do that, which can be a little tricky, and I have I'm using a computer, so it makes it even easier for me. Negative 1 is right here from this y-intercept. My slope is 1, so this one is going to go in an upward direction. But if you have any sort of unsteady hand or you're not using a ruler very carefully, you might get kind of wiggly lines and you're not exactly sure if your graphing was perfectly accurate. And can you see the problem I'm having right here? I do get a point of intersection, but that point of intersection is not easy to tell what it is. So I have to estimate what that point is. So 1, 2, 3.5 is what I would say. It's about 3.5 for x and about 1, 2.5 for y. So that's my guesstimate, and that's the problem with graphing method. 1, it's a little tedious, and 2, it's not always going to give you the answer right away. You have to kind of estimate. So that's why we move on to method 2, which is elimination. So elimination, I'm going to stack my two equations, x plus y equals 6, x minus y equals 1, and I'm going to add them. And because y on this equation has a coefficient of 1, and y on this equation has a coefficient of negative 1, when I add the two equations, it works out beautifully because the y will eliminate. I get 2x equals 7, and when I divide by 2, I get x equals 3.5, which I can confirm was my estimate up here. When I plug 3.5 back into the equation, I get 3.5 plus y equals 6, and when I solve for y, I get y equals 2.5, or 2.5. So my solution using the elimination method was 3.5, 2.5. So now I confirmed algebraically that that was indeed the answer. So this problem right here, I would definitely use elimination. It works out beautifully. It's very easy. Okay, but if we move along and we see this problem right here, this problem, I could graph it. This one's set up in y equals mx plus b. This one's not. I'd have to move things around, and I probably could do that. But again, graphing might not be accurate. So my second plan would be, could I eliminate? Well, my coefficient here is a 1 on the y, and my coefficient here is a negative 2. My coefficient on the x is a 4, and my coefficient on this x is a 1. Well, things don't line up, and also the numbers are not perfect. So I'd have to transfer things around, and then I would have to multiply equations by numbers. I could do that. It would work. But there's a better method here, substitution. If y equals 4x minus 2, then I can take this unit right here because it's equal to y, and I can substitute it in for the y in the second equation. So I'm going to do that. X minus 2, but instead of y now I'm going to write 4x minus 2 equals 24. Now I'm going to distribute x minus 8x plus 4 equals 24. I get negative 7x equals 20. Now I divide by negative 7, and I get x equals negative, oh my goodness, 6 and 1, no, sorry, that is completely wrong. 20 divided by 7 would be 2 and 6/7. Or if you want to leave it in fraction form, I would be okay with that, which would be a little bit easier right now. Now I'm going to plug this back in for x up here, and I get y equals 4 times negative 20/7 minus 2. This gives me negative 80/7 minus 14/7, which is 2, which gives me y equal to negative 94/7, which would be negative, what would that be? 1, 3 and 3, 13, negative 13 and 3/7. And this one here was negative 2 and 6/7. So kind of a messy answer, but my answer is finally, I'm going to write it in an ordered pair, negative 2 and 6/7, comma, negative 13 and 3/7. Imagine if you graphed that, that would have been tricky. Okay, let's try another one. Maybe this one will work out a little bit nice, I don't know, more even. So I have two equations here. Again, I have a choice. They are stacked and in order for elimination, but I think I see an x by itself and none of the coefficients line up. So I'm going to turn this equation around and solve for x. What that means is I'm basically going to add 4y to both sides, which is going to give me x equals 4y plus negative 19 or minus 19. Now, because I did that, I'm going to take this unit and I'm going to sub it in for the x in the second equation. So I have 5 times 4y plus negative 19 equals 15. I think I forgot a 2y in there, so let's go back. Let's look at that again. I have 5x, which I subbed in my x, but now I need to do plus 2y. Hopefully that you caught my error before I proceeded. And now I'm going to distribute. I have 20y plus negative 95 plus 2y equals 15. If I combine like terms, I have 22y plus negative 95 equals 15. I add 95 to both sides, and I get 22y equals 110, which you will find works very nicely. Y equals 5. Now, how do I get my x? I have to plug it back in. X minus 4 times 5 equals negative 19, which this is a form of substitution also. X minus 20 equals negative 19. If I add 20 to both sides, I get x equals 1. So my final answer here is 1, 5. Don't forget that if you want to do a check step, you can plug in x, 1 for x and 5 for y, and make sure that it works in both equations, which in this case it does. Okay, we'll do one final problem. Okay, 2x plus 3y equals 2, 12x equals 6y plus 4. Again, you have a choice here, but because we're learning this equation, this substitution method, we're going to use substitution method on this. So the one that I see that's easiest to solve is in the second equation. If I divide everything here by 12, I'm going to get x by itself. And you can choose, it can be either one. So I get x equals 1/2 y plus 1/3. Starting to look a little scary, but it ends up being okay. Now I have to plug it into my first equation. I'm going to plug in for x. 2. Instead of x, I write 1/2 y plus 1/3 plus 3y equals 2. I didn't forget this time. 2 times 1/2 is just 1y plus 2/3 plus 3y equals 2. Combine like terms, clean things up, I get 4y plus 2/3 equals 2. If I subtract 2/3 from both sides, I get 4y equals, this becomes 1 1/3, or if I want to keep it in fractions, 4/3. Divide by 4, divide by 4. Think about if you take 4/3 and you divide it into 4 equal parts, what do you get? 1/3. So y equals 1/3. Now if I plug 1/3 back into my equation, I would get, let's go back up and see. So I have y equals 1/3, and I'm going to plug it into either equation. Doesn't matter which one. So let's plug it into the 2x plus 3y equals 2. So I have 2x plus 3. Instead of y, I put 1/3 equals 2. That came from the top. Now when I solve that, I have 2x plus 1 equals 2. Subtract 1, I get 2x equals 1, divide by 2, and x equals 1/2. So my final answer is 1/2, 1/3. So it really wasn't too bad after all. So that is solving by substitution.